Welcome viewers. In this lesson, we want to start a new topic, sequence and series. Sequence and series. So what is sequence and what is a series? A sequence is a succession of terms or succession of numbers that are generated by some definite rules. When you have succession of terms or set of numbers that are generated by definite rules, and that is what we call sequence. So such number follow certain pattern. So and each term are generated by certain rules. The rules that rule can generate all the members of such a sequence, and that is what simply that is what sequence means. So they are what? They are set of numbers that are generated by some definite rules. Now look at here. Here are some of the sequence. Okay, before I move on, series. Series simply means summation of sequence or partial sum of a sequence. When you add sequence together, then it becomes what? Series. So we can say it's just partial sum of what? Of a sequence, or we say summation of a sequence. That is when you introduce this to each term. Now this becomes plus, plus, plus. Once you introduce this becomes series, and the same for all. So once you introduce the addition sign, you link them with addition sign, it becomes a series. Now we know what sequence is and what a series is. Now let's consider each of these sequence. You can see, let's study this carefully. You can see that the first term, when you add 3 to this, you get 7. Add 3 to 7, 10. It means each term of this is generated, or successive terms are generated by addition of a 3 to the first term. So you add 3, you get second, add another 3, you get 2, and that is how you continue. So now, another thing I want us to take from this is that we can generate a formula for this. Since the first term is 4, and each term is generated by addition of what? Of a 3. Then it means I can just say 3 multiplied by n, because you are adding 3 to each term. But for the first time here now, for us to get 4, then it means you add 1. So that when n equals to 1, you get what? 4. When n equals to 2, 2 times 3 is 6. 6 plus 1, 7. You can see we are adding 3. So that is multiple of a 3. So it means we can generate this sequence by this formula, such that our n is member of natural number. And we can also, another thing I want to call our attention to again, you see this 3 dot. This simply means that this is infinite sequence. So it goes to infinity. This is increasing and is tending to positive infinity. Let's consider the second sequence here. We have -3, -5, negative. So now this is decreasing because negative value. So this is moving downward. Now, what's the difference between this and this? So the difference here is just addition of -2. When you add -2 to this, -5, -5, 2 to this, it means we are adding negative number. So now plus negative number, so this will be multiple of this negative number, -2. But how do we get -2? What are we going to add to -2 to get -3 is 1, right? So you take 1 from this, -1. So that when n equals to 1, you have 2 times 1, 2. -2 minus 1, -3. When n equals to 2, 2 times -2, -4. -4, -1, -5. And you continue, as you continue to introduce your n, such that n is member of a natural number, so you get each of this term. This one is also infinite sequence. All are, so this one, like this one, If it stops here, it means it's a finite sequence, but it also continues. Now, let's move to the next one. Here, addition of positive number will generate. Here, addition of negative number will generate. Let's consider this. Here we have 3, we have negative 6, we have 12. What is adding, or how do we generate the next term here? Each term are generated by multiplying this, the first term by negative 2. So we multiply this by negative 2, you get this by negative, and that is how it continues. It means I can form a term, the n term for this, and the n term will be 3 multiplied by negative 2 raised to n minus 1, where your n is still member of this. So let's check that. When n equals to 1 is 0. Negative 2 raised to 0, that is 1. 3 times 1, 3. When n equals to 2, put 2 here, that is 2 minus 1, 2. 2 minus 1, 1. So negative 2 raised to 1, that is negative 2. Negative 2 multiplied by 2, and that is 3. So you continue to put in the value and the natural number as your n. Your n starts from another thing is that n is greater than or equals to 1. So your n starts from 1 to infinity. Let's consider, it means we are multiplying this by, here we are adding 3, here we are taking 2 from each term. Here we multiply by negative 2. Let's consider this now. Here we have 48, we have 12. It means you cannot multiply, you can't increase this and get to this. Definitely they are dividing. So you can see, if you observe this carefully, you can see that each term is divided by 4. How many 4 goes there? 12. 4 in 12, 3. 3 divided by 4, we have this. This divided by 4, we have, and that is how it continues. So now each term is generated by dividing the first term by 4, you get the second, you divide second by 4, and that is how it continues. So here, how do we generate the n term for this? Just like this one also, I can just write this as a 48 1 over 4 raised to n minus 1. You know, when you divide by 4, it means you are multiplying it by 1 over 4. You multiply by 1 over 4. Or you say you divide by 4, anyone. Either you write this or use this. Now let's consider the last one. Unlike this, the first 4 examples, this one is entirely different, because even if you multiply a number, if you multiply, there's no number, whole number you multiply by 2 to get 5. Multiply again to get 10 again, because you multiply 5 by 2, you get 10. Is it possible to multiply 2 also by this to get 5? That's not possible. It means you have to study this carefully. So how do we generate this now? The simple trick is generated by n squared plus 1. So n is still under the natural number and is greater than or equals to 1. So when n equals to 1, 1 squared is 1. 1 plus 1, that is 2. When n equals to 2, 2 squared, 4. 4 plus 1, 5. N equals to 3. 3 squared, 10. 10 plus 1, 9. 9 squared, 9 plus 1, 10. And that is how we generate each term. So this is simply what we call a sequence. And now, from these examples, sequence generated by addition of a term or subtraction of a term, you generate a sequence by addition of a number or by subtraction. You take a number from from each term, or addition of integers. Let me just put it in that way. Sequence generated by addition of integers or rational number is what we call a linear sequence. Linear sequence. Linear sequence. This linear sequence, another name is arithmetic sequence or arithmetic progression. Arithmetic progression. Sequence, we said all these are sequence, but we have some sequence generated by addition of integer. integer can be positive, can be negative. Here we have positive integer, here we have negative integer. It may be a rational number, either positive or negative. Sequence generated by such is what we call a linear sequence. Either you are adding a positive number or you are adding a negative number to generate each time. If it's not necessary to be rational number, let me just use number generally because it may be a rational number too. So sequence generated by addition of positive number or negative number is what we call linear progression. Now, look at this second two, the second and the third examples here. We generate each time by multiplication. You multiply by a number, either a whole number or a fraction. So sequence generated by multiplication or by division is what we call a exponential sequence. Exponential sequence, or we call it geometric progression. So now it means we have many form of sequence because this one is entirely different. Here is another sequence. So you can generate many sequence, depends on what you are working towards. So we can generate, we have some alternating, especially in series, alternate series, where you have a -1 plus 1, -1 plus 1. Maybe it's generated by just 1 raised of n. When n is even number, you get positive result. When it is odd, you get a negative result. So now here are some of the examples, and our lesson, this topic will be limited to these two types of a sequence: the linear sequence and the exponential sequence. So just a recap. Here are sequence. When you add a number or you take a number in order to generate the next term, we call it linear sequence or arithmetic progression, which is commonly known as a AP. When you generate each terms by either multiplication, you multiply by a number or you divide by a number, we call it exponential sequence, which is known as a geometric sequence. So in the